Question 7. Consider a geometric progression where a sub 1 represents the first term and a sub n represents the nth term. Each term of the progression is defined by the product of the previous term and the common ratio r. Here we've got s equals, and s just stands for the sum, equals a sub 1 plus a sub 2 plus a sub 3 all the way to some unknown term a sub n. So all this step right here is saying, it's saying S is the sum of all the terms of a geometric series. So it's using kind of fancy language here. That's all we're talking about. Talking about the geometric series definition. Okay, the next line, the derivation of the formula for the finite sum of a geometric progression where r is less than 1 is shown below with a mistake at a key step. Determine the step where the first mistake occurs. So since we're looking for where the first mistake occurs, we need to go in order. So starting with step 1, they've just got the definition of a geometric series. S stands for the sum equals the first term plus the second term plus the third term all the way to some unknown term. It could be the thousandth term, it could be the millionth term. We don't know. It's not the point. We're just saying this is the formula for however many terms a sequence has. Step 2, let's look at the reason. The reason is substitution. You'll notice the left side does not change. Stays S. First term is a sub 1. First term here is a sub 1. It's the same. First place we see a change is right here. A sub 2 has become a sub 1 times r. Now if we use just a really basic example, like 2, 4, 8, 16, is a geometric series where the common ratio is 2. Think about it. The second term is 4. Well, couldn't we rewrite 4 as the first term times the common ratio? Well, yeah. 2 times 2 is 4. 8, we could write 8 as the term before it, which is 4 times the common ratio. And we could write 16 as the term before it times the common ratio. That's all we're doing here. They're writing the second term as the first term times the common ratio. And then they're writing the third term as the first term multiplied by the common ratio twice. And the fourth term is the same thing as the first term times the common ratio 3 times. And then finally, some unknown term is being multiplied by the first term times the common ratio to the n minus 1 power. So we're just taking whatever the term is and we're multiplying it by the common ratio 1 time less than whatever that is. It's a little tough to wrap your brain around at first, but it'll come together. So step 2 looks okay. Step 3 says multiply. We're multiplying both sides by r. So we can see clearly S is being multiplied by r here, just like the reason stated. A sub 1 is being multiplied by r. That's just fine. A sub 1 times r is also being multiplied by r. So it looks like all of these are being multiplied by an extra r, including this last term. There's an extra r there. So step 3 looks fine. Step 4, we're subtracting SR from S. So let's be clear with the language there. We are subtracting SR from S. So this is correct right here. We're subtracting SR from S. So it should be S minus SR in this problem. So that means we're basically taking all of this in step 2 because this is S, and subtracting from it, we're taking all of this because this represents SR. Taking all of this in step 3 and subtracting it from step 2. So let's see if this makes sense. So if we're taking a sub 1 and we're subtracting it, or a sub 1r and subtracting it from a sub 1r up here, these should cancel out. This second term, r times r gives us r squared. So if we subtract that from this r squared, these cancel out. So as you can see, all of these are going to cancel out except right here at the end. So this is tricky. So let's think about r raised to the n minus 1 times r. When you multiply variables, you add their exponents together. So we've got an imaginary exponent of 1 there. So if we add n minus 1 plus 1, it just becomes r raised to the n. So these 1's are going to cancel out. And if this just becomes this, a sub 1 times r raised to the n, it's not going to cancel out with any of the terms from step 2. So let's look and see what hasn't canceled out. Well, a sub 1 hasn't canceled out, and a sub 1 times r raised to the n hasn't canceled out. But be careful, because remember, this is what we're doing. We're doing s minus sr. So that would be a sub 1 minus a sub 1 times r to the n. And you'll notice here, they've got a plus sign. So our first mistake in this problem, step 4. That was a heavy lift problem there.